right, the last thing we need to talk about in this unit are empirical and molecular formulas. I don't even get it. I know. Let's define what an empirical and a molecular formula are before we start. In order to do that, I need to go back to PowerPoint. I forgot about that. So find a place on your paper where you can write this up. There we go. Page 5 and 6. Okay, you know there's a whole number of different types of chemistry, and so there's a whole number of different types of chemists. So this is a scenario that could happen. Some researcher finds something and it gives it to an analytical chemist, and the analytical chemist says, you know what? This is what I found. I found your stuff contains carbon and it contains hydrogen. It contains carbon. For every one carbon, there are 2 hydrogens. Get it?
1-to-2 ratio.
Yep. And this chemist figured this out from doing experiments and data. Maybe burned it and saw what was left. And then perhaps another sample came in, and the person, the chemist said, you know what? I know that your compound has some nitrogen and some oxygen, and it is in the ratio of
2 to 5.
2 to 5. 2 moles of nitrogen to 5 moles of oxygen. Get it?
Yeah.
All right. So when someone has written the formula CO2, what are they really telling you?
That the carbon is 1-to-2 ratio of
That's
oxygen.
correct. That's correct. That is called the empirical formula. Hey, is this an empirical formula?
Yes. It's a 1-to-2 ratio.
It's not the simplest.
It's not the simplest.
Gotcha.
Its ratio would be the same as,
1-to-2.
Right there.
C1H2.
okay, so we get this so far, huh?
Yes.
All right, moving on. This has been really, really fractious today, so
What is the word fractious?
fractious means it's irritating. Okay, ladies and gentlemen, say thank you one more time.
Thank
'cause
you.
This would have been you. Writing. Okay. So, I want you to add one little addition here. Where it says determine the mass of each element in the sample. If percent is given, change to grams. It will make sense in just a moment. Okay, here is our first example, and you have the same example as well. What is the empirical formula? The empirical formula, one more time, is the lowest ratio of moles of a sulfur oxide compound that contains 50% sulfur and 50% oxygen. Remember, since percentage means parts of 100, you can change the percent sign to grams. Okay. Remember, we did our ratio method to determine the number of moles a couple of weeks ago. Let's write a little refresher for ourselves. When we did our ratio, you should have your given here, and on the other side, your wanted, your unknown. And then underneath, you are going to have, for these problems, you will have the molar mass from the periodic table in grams. And over here, you're going to have 1 mole. So given on top, unknown on top, and here is one of your mole facts. 1 mole is equal to the molar mass in grams from the periodic table. So, in looking at this problem then, we know we have 50 grams of sulfur. We would like to know how many moles that is. If I look on the periodic table, 32.1 grams of sulfur is a molar mass of 1 mole of sulfur. I do my math, and I figure out that is 1.558 moles of sulfur. I'm here to tell you right now, things get confusing. Label this, otherwise you're going to be like, what is that? Well, I don't know. Likewise, you have 50 grams of oxygen. How many moles of oxygen is that when 1 mole of oxygen has a molar mass of 16 grams? That means 50 grams is 3.125 moles. That's the mole ratio between sulfur and oxygen. Is that useful?
Yes.
Really?
No, it's
No,
not.
why is it not useful?
Because none is simple.
Well, first of all, I don't want to walk around saying all these numbers. And secondly, it's not a whole number ratio, is it? No. So what I'm going to do now is divide both of these by the smallest number of moles to get at least one of these to be a 1. Do you get that? Sam, what is this one?
2.006.
Which is a whole number that we'll call 2. 2.006 is what your calculator spit out. We know that is really close to 2. So instead of having this number, I divided everything by the smallest. So now I have a formula that's like this. Is that easy to work with?
Yes.
Mm-hmm.
It's
a whole number. What is the name of this compound?
Sulfur oxide. No.
Sulfur dioxide.
Sulfur dioxide. Okay. So we label properly, and that is our answer. Okay. Here is another example for you. A compound contains 54.1 grams of magnesium and 45.9 grams of phosphorus. Determine the compound's empirical formula. Stop right now and tell me what type of compound will be made when magnesium and phosphorus come together. An ionic compound where what comes first?
Magnesium.
Magnesium, and then so we're going to try to figure out, using our data, what the subscripts are right there. Okay, so They told us we had 54.1 grams of magnesium. How many moles is that? When we know from the periodic table 1 mole of magnesium is 24 grams. That would be 2.24 moles of magnesium. So you probably caught up with me and you figured out that 45.9 grams of phosphorus is equal to 1.481 moles of phosphorus. Can anybody tell me the next step without looking? What? Divide by the smallest. Go ahead and do that. Okay. So is this what I have?
Yes.
Are we done?
No.
What's wrong? It's not a whole number. What else is wrong? It's flipped, right? The metal has to go first. So this is what I would do. It's not good yet because you need a whole number. What do you suggest I do?
Round to 2.
Can't round to 2.
Multiply.
Multiply by the, what do you call it, the lowest common factor? Mm-hmm. So, like the formula, like we know the formula should be, it is Mg3P2. Alrighty. Here is a jingle, because you are not going to get this on the test. Okay, I think we need to change this to, okay, got it. Let's not till, but to. Okay, percent to mass, mass to mole, divide by small, multiply to whole. Got it? Percent to mass, mass to mole, divide by small, multiply to whole. I'm going to make you do this.
He's already doing it.
All right, when I say go, I want you to, say the jingle. On your mark, get set, go.
Percent to mass, mass to mole, divide by small, multiply to whole.
Oh, that was kind of terrible. Can we do this like, the choir teacher was standing here, please? When I say go, 1, 2, 3, go.
Percent to mass, mass to mole, divide by small, multiply to whole.
I think that might have been fabulous. Can you do that one more time, please?
No.
That was it? That's all you had? All right. Now do this. Close your eyes. And I can see you. Let's see if your eyes are closed. Yours are open. Close your eyes. All right. When I say go, you're going to sing the jingle without looking. Ready, set, go.
Percent to mass, mass to mole, divide by something, something to whole.
See, that's the problem. Now open your eyes and see what the something is, everybody. All righty.
You got this.
You got this. Let's hope.
Oh my God.
That's kind of fun, though.
You still recording?
Yes, you are. On the internet. But nobody knows who you are, so everything is fine. Okay, ladies and gentlemen, turn your paper over. I believe I gave you the definition of a molecular formula. Remember we talked about this is the empirical formula that the analytical chemist figured out? An example of a molecular formula would be this. Somebody could say, you know what, I found this. And the chemist, analytical chemists say, hey, but it's still in a 1-to-2 ratio. Yes, it is, but if this has a mass of 14 grams, my unknown has a mass of 28 grams. I wonder what its molecular formula is. Still a 1-to-2 ratio, but it's a multiple of it. And actually, there
We already have
is
this written
also
down.
a compound like that, which is still a 1-to-2 ratio, but its molar mass would be something I can't figure out without a calculator, which is really embarrassing. But that's the way it goes. Remember, I'm having a bad day. Okay. So a molecular formula is some multiple of an empirical formula. If somebody gives you the molecular formula and asks you to tell them the empirical formula, just reduce. People try to do all sorts of complicated math. Don't bother. Both of these can be divided by 4. So this molecular formula has the empirical formula of 2 to 3. Don't know what happened there. So far, so good. Now it gets just a tad more complex now, doesn't it? Yep, because there's more room on your paper. Huh. This is a way of keeping things straight. The first thing you have to do is remember the position of everything in here. This is how I remember it. What do you remember about the electromagnetic spectrum?
Origin.
The song, right?
Radio.
Waves,
Microwaves.
microwaves, infrared. Everybody sang that song?
Ultraviolet, gamma
Ultraviolet,
rays.
yep. You did so. Okay, so what I want you to remember is electromagnetic. E comes before M. Alphabetically, E comes before M as well. However, I think this is kind of fun. Electromagnetic spectrum. So you start with the empirical formula. Below it, alphabetically, is the molecular formula. And then I just remember anything on the right is mass. Anything on the right is mass. And it corresponds to whatever's on the left. Anything on just mass. Okay, this is how this works. I've got to close my ink layer before I move on. Here's a question. The molar mass of a molecular formula, guy comes and he says, hey, I found this stuff, and it has a mass of 283.88 grams per mole. And I took it to the analytical chemist, and he told me the lowest whole number ratio is 2 phosphoruses to 5 oxygens. What's the molecular formula? And you say, oh, I can figure this out. Give me a minute. E and just mass. So let's fill in what we know. Somebody told us here's the empirical formula, and somebody told us here is the molecular mass. You are smart kids. You can use a periodic table to find the molar mass of the empirical, can't you? Yep. There are 2 P's and there are 5 O's. Each P is 31. Each O is 16. When I add that all up, it's 141.943. I did a little rounding. You shouldn't either. So here's my X. Would you please tell me what the difference between these two? What factor? 2. 2.
So you just divide this one.
Yeah. So what should I do here? Multiply by 2, the same factor. If this goes up by a factor of 2, this should go up by a factor of 2. Is that correct? Yep. So here is the molecular formula. That seemed pretty easy. Okay, ladies and gentlemen, I'm going to close my ink layer and take a look and see that the next one is all on you.